Good evening, everyone. How are you all? We will start in 3 minutes, okay? Good evening, Ananya. Just wait for 3 minutes, then we will start. Good evening, Athira. Good evening, Meera. So, are you guys doing revision? Everyone, are you doing revision? Because revision is important. Good evening, Parul. Okay, Aditya. Okay, Arpita. Very good. Okay, just let's wait for 2 minutes, then we will start. Okay, good evening, everyone. Good evening, Sakshi. Good evening, Divya. Good evening, Anurag. Okay, let me share my screen. So, in the last few lessons, we have been learning Python to handle text and numbers. But biology is not just text, right? It has rules, it has patterns, it has meaning. So, BioPython is the tool that teaches Python how to understand biological data. So, from today onwards, we move from writing Python code to writing biological code. First of all, let's understand again what is BioPython. So BioPython is a library of Python which is specially designed for biological data. It teaches Python how to understand DNA, RNA or protein sequences. Without BioPython, Python only sees DNA as a text. But with BioPython, Python understands biology. So let's open our IDE, or should I say let's open our VS Code. So here I'm making a variable DNA and I'm storing some value inside it. So I'm storing a string ATGCGT and I'm writing print the type of my variable DNA. Let's run it. So here in the output, we can see that Python is telling us the type of this variable DNA is a string. Here Python is showing us that the type of our variable DNA is a string. means the value which is stored inside this variable is a string. So this proves that Python doesn't know that this is a DNA sequence. So Python only knows that this is a string which is being treated as a text. So till now we were storing the DNA sequences as strings. Now if we want Python to print the type of this variable DNA, not a string but a biological sequence. So here we will use Biopython. Because until and unless Python doesn't know that this is a biological sequence, we won't be able to perform biological operations like complement, transcription or translation. So first of all, we need to install Biopython because Biopython gives Python the biological intelligence. Now, to install Biopython, you have to open your command prompt. So here, let's search command prompt. So this is command prompt. You have to open it. Let's open it. Now this is a command prompt. And here you have to write a command pip install Biopython. So here in the command prompt, I have written a command pip install Biopython. So here PIP, what is PIP? So PIP stands for package installer for Python. Now when we want to install external packages or external libraries that do not come with Python, for example BioPython itself, or there is NumPy, there is Pandas, there are Matplotlib. So they are external libraries that don't come with Python. So to install these, we use PIP. So PIP is called package installer for Python. Okay. Now, after writing this command, you have to press enter here. And after pressing enter, you will see that BioPython has started to install. As I have already installed BioPython, so I'm not pressing enter here. Also, you can install it later using this class recording. For now, just listen and understand. Alright. Now, suppose that we have installed BioPython. BioPython is already installed in my environment. Now our next step is to import BioPython in our Python file. So this is my Python file. Here the name of my Python file is lesson7.py. So in this file we have to import BioPython. So to import BioPython in our Python file, here I will write a very simple code. So here I am writing import bio. Now here bio means the BioPython package that we installed or the BioPython library that we installed. So basically here bio is a container that contains all the BioPython tools that we are going to use. Now just like when we installed Python, we checked its version. Now in the same way, we are going to check the version of the BioPython that we installed. So to check its version, here we will write print, add parenthesis, write bio, which means BioPython, add dot, and then add underscore. Here you will see version. So click on it. So here we have written print bio dot underscore underscore version underscore underscore. So let's comment this program for a moment and let's run this. So here in the output, we are seeing some number. So this is the BioPython version that is installed in my environment. In the same way, when you will install the BioPython, you have to open your command prompt, write the command that I just showed you. And after writing that command, import BioPython by writing this code in your Python file, then check its version. So in the output, we are seeing the version of BioPython. Now the output clearly shows that we have successfully installed the BioPython and we have successfully imported BioPython in our Python file. Up to here, is it clear? Up to here, is it clear? Abhishek, you can see the class recording, okay? I will again tell you the command. Let's open command prompt. So this is the command prompt, open it. You have to write pip install Biopython. But I already told you that don't install Biopython right now. Just listen and understand. You can install the Biopython using the class recording, okay? For now, just listen. Alright, does anyone has any questions? What we did till here? Okay, so we have installed Biopython and we learned how to import Biopython in our Python file, and we learned how to check its version. So in the output, if you are seeing the version of Biopython, it means you have successfully installed Biopython and you have successfully imported Biopython in your Python file. Now, I am going to show you an example of how Biopython is organized inside our computer. Just try to understand it, alright? So I'm opening my file explorer. Okay, so here you can see that I have created a folder named Bio. So this is just a folder. It is just a normal folder like how we create any folder on our computer. Now here we are going to relate this folder to the Biopython library that we installed. Okay, so we are going to relate it here. So suppose that this bio folder is a Biopython package. Now, if I go inside this folder and open it, let's open it. So here you can see many folders like sequence, sequence IO, align, philo, entrance, PDB, blast, or you can assume that there are many other folders as well. Okay, just assume that these are not just the only folders, there are many other folders as well. Just assume it. Now, what does this mean? What am I trying to show you? So here this means that inside the Biopython library we have many tools. Inside the Biopython library we have many tools. So by creating this folder, I'm trying to show you that this is the Biopython folder. So we are relating the Biopython library to this folder to understand that there are many tools like this inside the Biopython folder. Now here each folder represents each tool that Biopython provides us. Now look at this first folder, or should I say the first tool of Biopython. Now if I go inside this folder, let's open it. So here you can see another subfolder with the same name called sequence. So what we did, we went inside the Biopython folder. Inside the Biopython folder, we went inside the sequence folder. And inside the sequence folder, we are seeing a subfolder with the same name called sequence. Now this sequence is a tool which is designed specifically to work with biological sequences like DNA, RNA or protein. So this tool, so here sequence is a Biopython tool that we are going to use. Okay, so this tool makes Python understand that here that this is a biological sequence. This is a biological data. This is not just a normal string. This is not just a normal text. So here sequence tool inside Biopython will make Python understand that this is a biological data, not just a normal string. So today we are going to learn this sequence tool. Okay. Now, by writing this code, import bio, we imported the whole Biopython package inside our Python file. But today, what we actually need from the Biopython package, we need the sequence tool. So now just like we imported Biopython in our Python file, in the same way, we will import the sequence tool inside our Python file. Okay, so to import the sequence tool, we will write here, we will write from bio.sequence import sequence. Now, how many of you understand this line from the example I just showed you? I showed you the folder example in my file explorer. So by that example, what do you understand by this line? Can anyone tell me? I will also explain it, but I need you to tell me what does this line mean. Can anyone explain? Can anyone explain me what this line means? Anyone? Yes, very good, Aditya. Very good, Siddesh. Yes, Parthiv. Yes, Abhay. Very good. Very good, Divya. Yes, you all have understood it really well. So here, this lines means by writing this code from bio.sequence import sequence. So here from bio means from the Biopython package, and then I have added dot. So here dot means dot operator. So dot means inside this, means inside bio. So from the Biopython package and inside the Biopython package there is a sequence module, and from the sequence module we are importing a sequence class. Now, just like we used two terms like folder, subfolder, right? In the file explorer, we use terms like folder, subfolder. So here in the BioPython, we use terms like this is module and this is a class. So inside the BioPython library, there is a module called sequence, and from this module, we are importing a class called sequence. And here we just learned that what this sequence tool is, why we are using the sequence tool, because this sequence class will make Python understand that this is a biological sequence and this is not a string. So we have imported the sequence class by writing this code. Now how to use the sequence class? So this is also very simple. What we will just do, we will write here sequence and we will write our DNA sequence inside parenthesis. Now this is very simple. This is how we use this sequence class. So we have imported the sequence class inside our Python file and this is how we use it. So before my DNA sequence, I have written the sequence class. Now if we run this program again, now this time what will Python print me the type of my DNA? Can anyone tell me what will Python will print me the type of my DNA here in the output? Anyone? Can anyone tell me? Yes, Zilam, they are nucleotides. This is now a DNA sequence. Okay, Pranjali. Okay, Ahmed, very good. Okay, so here we understood that this sequence class has made Python understand that this is a biological sequence, right? So let's now run our program. So here in the output, what are we seeing? We are seeing that this is the class. The type of my DNA is bio.sequence.sequence. Means this is a sequence class that comes from the sequence module and which is inside the BioPython library. So this is what the type of my DNA Python has printed it. Is that clear? Does anyone has any doubts? Aditya, is it clear now? Mohammed, you can re-watch the recordings as we have moved on very far. If I tell you right now how to download Python, so this is not the today's topic. Okay, BioPython. Okay, to download the BioPython, you have to open your command prompt. Let's search for command prompt again. Okay, so this is the command prompt. You have to open it and here you have to write a code pip install biopython. Now after writing this command you have to press enter and your Biopython will get installed, okay? But install it after class, as right now we are understanding what Biopython does, okay? Is it clear, Mohammed? Okay, so I think it is clear how to install Biopython and then how to import Biopython in our Python file. And then we understood about the sequence class, that Biopython has many tools, means Biopython has many modules, and inside those modules there are many classes. And from that many classes, today we are learning about the sequence class, which tells Python that this is a DNA sequence. And we have also printed the type of our variable DNA here. So Python has printed us. Now this time Python is not printing a string. For example, if I remove this sequence class and run this program again, now this time Python is printing me string, that this is a string. So here we are not using BioPython. In this program here we are not using the sequence class from BioPython. So again Python don't know that this is a DNA sequence. So that's why Python is printing string. So what we will do, we will use the sequence class from BioPython. Now let's run it again. So here we are seeing that Python now know that this is a biological data. Okay, now let's print our variable DNA. So we know how to do it, how to print our variable DNA. We will simply write print and the name of our variable. Now let's run it. Now here, by printing our variable DNA, we are no longer giving an instruction to print a string. Now here, for the first time, we are giving an instruction to print a biological data. So here in the output, we have created our first DNA sequence. So this is our first DNA sequence. Now we can perform our biological operations on this DNA sequence. We have many biological operations. We have complement, we have transcription, we have translation, and there are many others as well. But today we are going to learn about the basic biological operations. Okay, you must all have heard of complement. Can anyone tell me what is a complement? If I ask you what is a complement, okay, Light, yeah, okay, whatever your name is, it's not your real name. I said just understand what we are learning right now. You can perform the practical part by watching the class recording. Just understand what we are learning right now, okay? Yes, very good, Ananya. Very good, Pranjali. Yes, Atharva, very good. So you all know what does the complement means. So here we are going to perform the complement biological operation. So if we want to print the complement sequence of this DNA sequence, so what we will do? We will write print, then we will give the name of our variable, which is DNA, because inside this variable we have stored our DNA sequence. So obviously we will give the name of our variable DNA. Then we will add dot. So here dot is it is called dot operator. Now whenever we want to call a function, we will always add dot. We have learned that print is a function. We learned about length, that length is a function. So similarly, to perform these basic biological operations, there are functions written inside BioPython package, inside the sequence class module, and then inside the sequence module, and then here the sequence class. Inside the sequence class, there are many functions written. So we are using those functions which are written inside the sequence class. And one of the function is complement. So here we are going to call the function complement, and then we add the parenthesis at the end of it. Just like we learned that we write print and we add parenthesis, right? Because we give because here we give our input inside it. So in the same way, this is a function. So we write it, the name of the function and the parenthesis at the end of it. Okay. So here in this line, what are we trying to do? We have called our function print, and inside this we have given our input, that I have given the name of my variable DNA, because inside this variable this is my DNA sequence stored, and upon this variable I have called a function called complement. Now this function will print me the complement sequence of this DNA sequence. Let's run it. So here in the output, we are seeing that this line print DNA has printed us our DNA sequence ATGCGT. So it is the same ATGCGT. Now this line, this fifth line has printed us the complementary strand of this DNA sequence. So we already know that in biology there are only 4 bases, A, T, G and C. So these 4 bases have special type of bonding towards each other, and we already know that A always binds with T and T always binds with C. Similarly, G always binds with C. Okay, A always binds with T and T with A. G always binds with C and C always binds with G. And this is how a complementary strand is made. So you can see how, with the help of Biopython, by writing a simple line or by calling a simple function, we printed the complementary strand of this DNA sequence. So what we understood by performing this biological operation, that with only one line, here we have written only one line, and Biopython gave us the complementary DNA strand. We did not write the logic ourselves. We did not write anything from scratch just to print the complementary strand. So here Biopython already knows biology. We simply call the method here. This is also called method. So here we simply call the method, and whatever we wanted to perform, we just simply call the method which is already written inside Biopython. We called it, and the answer and we are seeing the result in our output. Does anyone has any questions about this biological operation complement? Is it clear? Does anyone has any questions? Okay, very good. So now, just like we performed one biological operation, in the same way we have transcription. Okay, let's comment this line. We have transcription. Everyone knows what is transcription, that it is a process of converting a DNA into RNA, right? So here that is what we will be going to do inside our Python using Biopython. Now to perform transcription, we will simply write print. We will give the name of our variable DNA. We will add dot, because whenever we want to call a function, we will add dot, and here dot is called the dot operator. Now here I will call the function that will perform the transcription for me. So here the name of the function is transcribe. So here you can see transcribe. Click on it and add parenthesis at the end of it, because as we just talked about, that this is a function, just like print is a function and we add parenthesis. Similarly, transcribe is a function which we are calling. So here we have called the transcribe function upon our variable DNA. So here this method will perform the process of transcription upon my DNA sequence. So let's run it. Now here in the output, we are seeing our RNA sequence. We know that what is transcription? It is the process of converting DNA into RNA. So here, this is my DNA sequence. This fourth line has printed me my DNA sequence, and this line has printed me my RNA sequence. So we know that whenever we see U in place of T, that means this is a RNA sequence. So we can say that Python has correctly printed us our RNA sequence, right? So see how easy it is. We are not doing anything ourselves. We are not writing any logic. We are simply using the functions which are already written inside BioPython. We are simply calling them, and see how easily we just converted our DNA into RNA. Now, similarly, we also learned about translation. And what is translation? It is the process of converting RNA into protein. Now, just now we saw that this line printed us our RNA sequence. So what I will do, I will just store this inside a variable called RNA. Now, we just saw that here I wrote the name of my variable DNA, because inside this variable, this is my DNA sequence. And upon this variable, I have called the function transcribe. So this function performs, it converts the DNA into RNA. So I have stored this inside a variable called RNA, just like I have stored this DNA sequence inside the variable DNA in the same way. So if I write print RNA, the name of my variable, and if I run it again, so again it will print me, see here in the output, again it has printed me my RNA sequence. So what I just did, I only stored this inside a variable, because we are going to perform translation now, and we know that to perform the translation, we do it with RNA sequence. Now what we will do, we need to perform translation. So here I will write print. Now what we will do here, we will give the name of our variable RNA, because translation is only performed on RNA sequence. So that's why I stored this line inside the variable RNA. Now here we will add dot, and we will call the method translate. Here we can see translate. Here we will add parenthesis at the end of it. Now what will this line do? This line will print me a protein sequence. So here on this variable, here I have written the name of my variable RNA, because inside this variable I have stored an RNA sequence, and upon this I have called the function translate, which will perform the process of translation, means the conversion of RNA into protein. So let's run it. Now here you can see that this fourth line again printed me my DNA sequence. This eighth line has printed me my RNA sequence. Here we can see U in place of T. And this line has printed us a protein sequence. So here we are seeing MR. So MR, what are MR? So here M stands for methionine, R stands for arginine. So this is a protein sequence. So what we just did, we just only called the function. So this complement function will print us the complementary strand, transcribe function will print the RNA sequence, and translate function will print the protein sequence. Is there any doubt in these three functions that we just performed? Is it clear? Is there any doubt? What we just performed? Okay, Athira, what do you want me to re-explain? Yes, Zilam, it is possible. You have to write your code how you want to print it. Dwaipan, what code are you talking about? See, we are not Dwaipan. See, here we are just calling the function. These are already pre-written. Scientists already made it. What we are doing, we are just using them. See, for example, you have your mobile phone and you download the apps from the Play Store, right? You don't create the apps yourself. You download it. So in the same way, here we install the BioPython and we are using all the tools which are present inside BioPython. Okay, so we are not writing anything ourselves. We are not doing anything from scratch. We are only using the tools which are already made by scientists, which they stored it inside the BioPython. Okay. Vidasri, what do you want me to repeat? Can you please specify? Athira, can you please specify what do you want me to repeat? Okay, from translation, okay. Okay, from translation, let's understand it again. So here what we did, we have written the name of our variable DNA, right? And inside this variable, we have stored a DNA sequence. We know this, right? This is clear to us. Now we want Python to print us an RNA sequence from this DNA sequence. So what we did, we called a function called transcribe. So this transcribe function will print the RNA sequence. As we already know, in biology, there are two terms. There is transcription. Okay, let's write here in comment. Transcription. And here, let's write translation. Right? We have already learned this in biology. There are two terms, transcription and translation. Now, what does this transcription do? It converts DNA into RNA, and in translation, it converts RNA into protein. So, the central dogma, we all have heard about central dogma in biology, that the central dogma is DNA into RNA into protein. So here we already have created our DNA sequence which we stored inside the variable DNA. So upon this variable DNA, we have called the function transcribe, which will perform the transcription method for us. So here we have stored this line inside a variable RNA. And when we wrote print RNA, so what will this line do? This line will print us the RNA sequence, and then it will get stored inside the variable RNA. And when we write print RNA, let's run it again. So Python will print us RNA sequence. So here in our second line of the output, we are seeing an RNA sequence. Now, in the central dogma, we learn about DNA into RNA. Now, we have completed DNA to RNA. Now, let's talk about translation. So, translation is about RNA into protein. So, what I have did here, I have written the name of my variable RNA, because inside this variable RNA, my RNA sequence is stored. So, here I have called the function translate, which will perform me the process of translation. Just like here, let's understand here print. Now, what is the function of the print? The function of the print is to display something on the screen. So here print is doing its work. It is displaying me on the screen. In the same way, what is the function of translate? So the function of the translate is to print me a protein sequence. So I have called the translate function upon my variable RNA, because inside the RNA I have stored the RNA sequence, which we can see in the output AUGCGU. So this is the RNA sequence. So here I have called the function translate upon my variable RNA, and when I wrote print RNA dot translate, so it has printed me the protein sequence. So it has printed me the protein sequence from this RNA sequence. Is it clear? Is there still any confusion? Okay, Divya, Athira, is there still any confusion? Vidasri, what basics? Okay, are you talking about the ATGC? So here, see, we already know that in biology, we have only 4 bases. So here, see, let's print the complement again. Okay, let's uncomment it and comment these. Okay, we are running this program again. Okay, Vidasri, we are running this program again. Let's run it. So here in the output, we are seeing that this complement function has printed us the complementary sequence of our this DNA sequence. So here in biology, we only have 4 bases A, T, G, C, and A always binds with T and T always binds with A. Similarly, G always binds with C and C always binds with G, and this is how a complementary strand is made. Okay. Vidasri, is it clear? Yes, Ayush, you are very right. Okay, Athira. Yes, Anil, we will perform it in our upcoming classes. Today we have just started Biopython. Okay, Sakshi here. Look here. Sakshi. See, what is this? This is print, right? Sakshi, now can you tell me why I have added parenthesis after print? Sakshi, reply. Sakshi, here text me in the chat box why we add parenthesis after print. Sakshi, can you reply why we add parenthesis after print? Yes, so Sakshi, see, if I want to print something on my screen, so suppose here I want to print your name. Okay, so what I just did here, inside the parenthesis, I gave an input. What I did, I gave an input. So in the same way, here we are just learning. In the same way, just I'm saying that print is a function, right? I am saying print is a function. And what is the work of the print? To display something on the screen, right? If I run it again, so in my third line of the output, I am saying your name Sakshi. So here I have given an input and Python is showing me an output. Here we give input, just like we talked about that we give instructions to the computer. So here Sakshi is my instruction which I have written inside parenthesis. So what we are doing by adding parenthesis, we are giving instructions, means we are giving input. So in the same way we give input and Python gave us output. So in the same way as I'm saying that print is a function and the work of the print is to display something on the screen, similarly complement here is a function. That's why I have added parenthesis at the end of it. Similarly, transcribe is a function, translate is a function. So these are functions which are written inside the sequence class. So it is mandatory that we add parenthesis because it is a function. Okay, we are not talking about functions in detail, just understand it. If we want to write some function, we give an input. So here for example, see my cursor here, this is complement and I have added parenthesis at the end of it. Now inside this parenthesis we can give some input. Okay, when we will move forward we can give some input inside those parentheses as those are functions. Is it clear, Sakshi? Vidasri, that is syntax, right? Just like we have some rules in English that if I'm talking in past, I will use was and were. If I'm talking in English, I will use will and shall, right? In the same way, this is the Python syntax that if we are using a function, we will have to add parentheses at the end of it. Ashwini, kindly don't perform right now, just understand, okay? You can text me in the group later, whatever you are facing. Just right now, just understand. Yes, very good, Ashwini. Anyone does have any question regarding what we just did today? Is it clear? We talked about three functions today. We talked about complement, we talked about transcription, we talked about translation. Is there any confusion in these three functions? Okay, so let's talk about one more thing. So here what we did, firstly we printed the DNA sequence, then we printed the RNA sequence, and then we printed the protein sequence. Okay, let's store it inside the variable protein. So here I will make the variable protein. So I have stored RNA dot translate, means RNA in my variable RNA, there is my RNA sequence upon which I have called the function translate, which will perform the method of translation. So here I will write print protein. So here what we did, we performed the central dogma. Firstly the DNA, then the RNA, and then the protein. So here what we did, we called the translate function on our variable RNA, because this variable RNA contains our RNA sequence. So in central dogma, we talk about that firstly there will be DNA, just like we did here. Then secondly, there will be RNA, that's the transcription. And then after RNA, protein will be made, and that's the translation. But in Biopython, we can do one little shortcut. So here I have written RNA.translate, means I am printing the protein sequence from the RNA sequence, right? And that is the most important central dogma in biology. What if I write here DNA? Now, anyone can explain me, I have written DNA.translate. Now, this means that I have written the name of my variable DNA, which stores a DNA sequence, and upon my this variable, I have called the function translate, means translate performs the method of making the protein, right? So here, what I am trying to do, I am trying to print the protein sequence by calling this function translate. I am trying to print the protein sequence directly from DNA. Here, firstly, I here wrote the RNA variable, but here I have changed it to DNA. Now, anyone can tell me what will be the result of it? Will it give me a protein sequence or will it give me an error? Is it possible? Will it print me a protein sequence from a DNA sequence? Is it possible? Okay, okay. Okay, Divya. Okay, Siddesh. Very good, everyone. Yes, as we are talking logically, that I just told you about the central dogma. Only first of all there will be DNA. Only after that RNA can come, and only after that protein can come. Right? That is the basic logic of the central dogma. But here in BioPython, let's run it. Okay, so I'm making a comment here. So I'm only printing a DNA, and here I'm only printing the protein. Let's see if this line will give me an error or if this will print me a protein sequence. Let's run it. So what are we seeing in the output? We are not seeing any error. We are seeing the protein sequence which we printed from the RNA, right? Here I wrote RNA first, which we performed. So we performed the translation from the RNA sequence. But now we performed the translation from the DNA sequence, means I just printed the protein sequence from this DNA sequence. So in central dogma, it is impossible to print protein sequence from directly DNA sequence. But in BioPython, here BioPython give us, we can say, a shortcut that we can directly print the protein sequence from the DNA sequence, because we are doing programming. So everything is working behind of it, right? Everything is working behind the scenes. So here BioPython can directly print us the protein sequence directly from the DNA sequence. So what we just did, we wrote the name of our variable DNA, inside which our DNA sequence is stored, and we call the function translate, which performs the method of translation, means which make the protein sequence. So we can say that this is a shortcut which we can do in BioPython. But in actual biology, in the central dogma, it is not possible. But in BioPython, we can do this. Is it clear? Abhay, what are you talking about? It has thymine, so it can't read. Yes, Ashwini, if you give a DNA sequence and you want to print a protein sequence directly from DNA sequence, so yes, Biopython can do it and you will call the translate function. Okay. Yes, protein is the same. Okay, let's print the RNA as well. Let's print the RNA as well. If I uncomment it. Okay, so here what we are doing, we are printing the RNA. Let's write, let's print RNA dot translate. So here I have written print RNA dot translate. So inside this here my RNA sequence is stored, which I have stored inside the variable RNA. So here I am performing the method of translation from RNA, and here I am performing the method of translation from DNA. So obviously both of these will print me the same protein sequence. Let's run it. So here in the output, we are seeing that this 10th line has printed us the protein sequence MR, and this program, 12th and 3rd line, this has printed me the same protein sequence MR, because the DNA sequence is the same, right? DNA sequence is this ATGCGT. So it will make the same RNA sequence and it will make the same protein. So that's what I'm saying, that the work is being done behind the scenes. So that is why we are calling it a shortcut, that we can directly perform the method of translation from DNA. Okay. Any other questions? If you have any other confusion about it? Okay, so I will share some practice questions here. I have made a practice worksheet. Okay, so I will upload it in the Google Classroom. It has what we learned today, it contains all of it. Okay, whatever we have talked about today, whatever we have learned today, this worksheet contains all of it. Again, this is not an assignment, this is just a worksheet for your practice. So I will upload it in the Google Classroom so that you can practice yourself. All right. Now what matter is that now you know how and where Biopython fits in bioinformatics and how we use Biopython. Okay, so everyone try to perform this worksheet. Also, it's not mandatory. You can do it at your own time. Okay, what do you want me to repeat? RNA? From RNA. Okay. Okay, let's see again. So here, let's remove this complement line. Here, in our first program, we printed DNA. This one is clear, right? Here, we stored a DNA sequence. We used the sequence class from the Biopython and we made it, and we made this a biological data and we stored it inside the variable DNA. Here, in this program, we printed the DNA. Now we wanted to perform transcription, means we wanted to print RNA sequence from this DNA sequence. So what we did, we used the method, we called the method transcribe. So to perform the method of transcription, we called the function transcribe upon our variable DNA, and I stored this inside the variable RNA. Okay, and then I printed RNA, which means that the transcribe function will perform the method of transcription upon this variable DNA. Inside this variable DNA, there is this DNA sequence. So the method of transcription, the process of transcription will be followed upon this DNA sequence, right? Now this line will print me the RNA sequence which I have stored inside the variable RNA, and then when I write print RNA, this will print me the RNA sequence. Let's run it again. So here we are saying that this is our DNA sequence. So this 3rd and 4th line. So this program has printed me a DNA sequence and this program has printed me an RNA sequence. So here whenever we see U in place of T, that means this is an RNA sequence. We only called the transcribe function upon our variable DNA. We just simply stored it inside a variable and we printed the variable. Okay, is it clear? RNA is clear? Ayush, we will talk about that later. This is just an introductory session about the Biopython. Okay, we will talk about this later. Okay, Vidasi, then okay, next let's talk about translation. Here transcription is clear, everyone. Transcription is clear. Everyone tell me, transcription is clear or not? Does anyone has any confusion till transcription? Okay, let's talk about translation again. Now we talked about the central dogma, right? That firstly there will be DNA, then there will be RNA, and then there will be protein. So let's make a variable protein. Here now what we will do, we can give the name of our variable RNA and we can also give the name of our variable DNA, just as we have talked about. Biopython gives us a shortcut. So if I write the name of my variable RNA, I will add dot here because I want to call the function and the name of the function is translate. Now this function will perform the process of translation, means the protein sequence from the RNA sequence. Now I will simply write print protein. Okay, let's run it. So here in the output, we are seeing that this has printed me DNA sequence. This program has printed me RNA sequence and this program has printed me the protein sequence. Now, if I write DNA here in place of RNA, now here I have given the name of my variable DNA. So we talked about that we can call the translate function either on the RNA variable and we can also call the function translate on our variable DNA. We can call it on both of these variables as Biopython gives us the shortcut. Let's run it again. So again we are seeing the same protein sequence MR. Okay, is it clear? Yes, there is reverse transcription as well. Yes, Arpita, we can get. Okay, let's talk about reverse transcription now. Okay, Ayush, send me the screenshot of this. Perform this in your VS Code and send me the screenshot in the group. Let's see the output. Yes, Zilam, if we see here, if we directly print the protein, Python always give us only one word. If we want 3 words, we can write a code for that. Okay, but Python automatically Python automatically prints us only one word. So here M stands for methionine. So here Python has printed us M. Here R stands for arginine, so Python has printed us R. Okay, if we want 3 words character, so we have to write a code for that. Ananya, see here we are talking about these functions, right? We are talking about transcribe function, we are talking about translate function. So these functions are written inside the sequence class. So if we want to use this function, we will have to import the sequence class. So we will have to write from bio.sequence import sequence. Okay, because here we have used the sequence class to make Python understand that this DNA sequence, it is an actual DNA sequence, it is not a string. So if we will not use the sequence class here, we will not be able to perform transcribe or translate because Python doesn't understand biology, but BioPython understands biology. That's why we will import the sequence class and then we can use these functions. Is translation clear? I can repeat translation again if anyone wants me to. We can do it again. Is it clear? Okay, so So this is the worksheet that I have created. I will upload it in the Google Classroom, so you can do it at your own time. There is no headache, and there is no due date. Okay, this is just a worksheet. You can upload your worksheet in the Google Classroom as well. And again, this is not an assignment. Okay, it's just for your own practice. What do you mean by ANOL? Yes, Janvi. Shrikant, what are you talking about? Which error are you talking about? I'm still not getting you. Which error are you specifically talking about? Can you tell me? Here, if you're talking about that, if we don't use the sequence class, okay, let's not use the sequence class here, remove the sequence from here. Now, this is only a string. This is not a DNA sequence. This is only a string. So here we have performed the transcribe, we have performed the translate. Okay, let's run it. We can see if in the output we can see an error. So here, see, we are seeing an error. Python doesn't understand what transcribe is, right? So what we did, we removed the sequence class from here. So Python doesn't know that this is a DNA sequence. Now that Python doesn't know that this is a DNA sequence, so Python is not able to perform the process of transcription for us. So that means Python doesn't know that transcribe is a function, because this function are only written in the sequence class. Okay, let's write sequence again here. Now, here we have written the sequence, which means this tool sequence has made Python understand that this is a DNA sequence. Now, these functions are written inside the sequence class. Now, if I will run it, this time I will not see any error, because this time Biopython is making Python understand everything. Okay. Yes, yes, Raj, I will share it. I will share in the Google Classroom. Also, I will share the worksheet. Shrikant, if you will not follow the syntax, you can see an error. If you will not add parentheses at the end of the function, you will see a syntax error. Okay, you can see any error at any time if you will not follow the rules. Ayush, you need a laptop for this. Okay, kindly get a laptop as soon as you can, because you can only perform this inside laptop, because you will be downloading the Python and then you will be working with the sequences. Yes, Ananya, that's what we did. Here, see, that's what we did. We made the variable RNA, we made the variable protein, right? So these are variables, we printed the variable, and here inside this variable, I have stored this, that this line will print me the RNA sequence, and I have stored it inside the variable. Yes, Vedasri, you have to write this line, just like I told you. I showed you an example right here. See, I showed you this example by folder, that this is the Biopython folder. Let's open it. And inside this Biopython folder, there are many tools. But today we are talking about this module, sequence module. So here, see in the first line, this is the Biopython folder which I just showed you. And this is the sequence folder. Here, this is the sequence folder, and inside the sequence folder, this is the sequence. Means we have opened the Biopython library. Inside the Biopython library, there is a module called sequence, and inside the sequence module, there is a class called sequence. Let's open this folder as well. Now, inside the sequence class, we have these functions written. So here, these are the functions: complement, transcribe, translate, that we today performed. Okay, so these functions are written inside the sequence class. Okay, Vedasri, so if we want to perform the biological operations, that's why we are using BioPython. Okay, is it clear? You have to write this first line because you are importing the sequence class, because these functions are written inside this sequence class. That's why we have installed biopython. Here bio means biopython, and inside the biopython there is the sequence module, and inside the sequence module there is the sequence class. And by writing this line, we are importing the sequence class inside our Python file, and then here we used the sequence class. This is the class, this is a module. Let's hover on it. If I hover here, so see, it is showing me module. If I hover here, so see, it is showing class. Okay, so here we have imported the sequence class inside our Python file, and here I used the sequence class, and this made Python understand that this is the actual DNA sequence, and that's how we were able to perform these biological operations. Ananya, we did that as well. Here, see, if I write print, I'm writing the name of my variable DNA dot, and I'm calling the function complement. So here we are directly printing the complementary strand from our DNA sequence by writing this line. So here I have not stored it inside the variable. But if you are talking about this, you have to make a variable, because you can't use all these line again and again, right? So it's necessary that you create a variable here to store your DNA sequence and write and use the sequence class. Ayush, again you need a laptop. Okay, okay, then everyone, if you have still some confusion about today's class, just rewatch today's class recording. Okay, everything will get clear. Also do the worksheet which I have created, and I will upload it in the Google Classroom. Okay then everyone, have a good evening.